Alright guys, we are going to solve radical equations today. We're going to solve radical equations. So, there are some rules you must follow. Rule 1, you need to isolate your radical. Then secondly, you're going to square or cube both sides. How do I know which one to do?
The number.
Which number?
Index.
The root, the index, yes, both are the same. Yes, the root or index will tell you how to get rid of that radical. But the square root, you have to square both sides. Cube root, you have to cube both sides. Once the radical is gone, you can solve for x. We do have to check our solutions right here, especially when it's a square root, okay? Because what can't happen in square roots? If we're looking for real answers only, we can't have negatives, right? So what's nice though is cube roots don't have any restrictions. Those are good.
Adam, I swear to God.
Shh. Please stop. Thank you. So what we're going to do is we got to check our square roots. Because if I plug something in, let's say I have just like the square root of x, and I solved my problem, and I got x was equal to -2, that would be an issue, right? Because I can't plug that back in. But if my original problem, let's say it was 2x plus 5, like that under my radical. Even though my answer is negative, that's okay. That becomes what? -4 plus 5, which is a positive 1. So don't think a negative answer means it's not going to work. Always plug it back in to see what happens. Okay? Sometimes, when we plug it back in, we might get like square root of -3, but then that's also equal to another square root of -3. In this case, it's okay because we're getting a true statement. Those are equal to each other. So in this case, that answer would be fine. All right, so we're going to get an example of all the different kinds along the way. All right, ready, set, go?
Nope.
Here we go. Here we go. I have the square root of 2x minus 1 equals 3. Is my radical already isolated? Yes. So let's go ahead and bring a power to both sides. What power are we going to do? 2, because my root is 2. So if we square both sides, this gives me what? 2x minus 1 equals 9. Yeah. Then we get to add the 1 over. And then divide by 2. My original was a square root, so let's make sure 5 is okay. 2 times 5 minus 1, it will not give me a negative number, right? So 5 is good. Maybe, if it lets me. Okay, fine. It's not going to let me do it. Boop. X equals 5. Okay? My next one, 7 minus the cube root of 9c is equal to 4. Is my radical by itself? It is not. What is attached to it? 7 and a -1. Okay, so which one are we going to move over first? Let's subtract 7. Okay, subtract the 7 first. This will give me negative cube root of 9c is equal to what? -3 now? Now we got to get rid of that -1, so it becomes positive cube root of 9c equals a positive 3. We just divide it by -1. Now my radical is finally by itself, so what are we going to do to both sides? We're going to cube both sides. Good. So radical is gone. We have 9c equals what? 27? Divide. Yep. We get c equals 3. Since it came from a cube root, no restrictions, so we know it's just equal to 3. Not too bad, right? I think this is easier than what we did. last week. No. Questions? Okay. Here we go. 3 and 4. Number 3 is the cube root of x over 2 equals the cube root of x minus 7. What do you notice different about this one? There are 2 different radicals this time, right? Are one of those radicals already by itself, though? Yes. So since the one on the right is already isolated, you can go ahead and go to step 2. So what power are we going to bring to both sides? We're going to bring a power of 3 to both sides. So the right-hand side, everything in here gets cubed, right? So my numerator is now just x, but my denominator is 8. Yes, we had this cube root of x cubed and then 2 cubed. The whole fraction got cubed, so each piece of my fraction got that power. And then that equals just x minus 7. Are we good with this? All right, Langston wants to multiply by 8. Do you agree? I agree too. So that gives me 8x minus 56. I'm going to subtract this 8x back over here to get negative 7x equals negative 56. So x equals 8. Good. Should I check this answer?
Yeah, just plug it in.
It came from a cube root, so I don't have to. So. Oh, hold on. Wait for it. There we go. No! Come on. There we go. So we get x is equal to 8. Questions on 3? Ready for 4? Come on. Thank you. Here we go. Number 4. What's attached to number 4? A 2. So how are you going to get rid of it? Divide both sides by 2. So now I have the cube root of x minus 1 is equal to 3 over 2. Now we will cube both sides. Good. Remember, when we cube a fraction or bring a fraction to any power, both pieces of the fraction get the power. So my left-hand side is just x minus 1. But 3 over 2 becomes 27 over 8. Last but not least, we are going to add 1, but what am I really going to add? 8 over 8, right? Is that okay? Do you all understand why I'm going to add 8 over 8? Because that is 1, right? But since we're adding to 27 over 8, we need the same denominator. So that technically cancels out, and we get 35 over 8. Huh? Nope. If you multiply by 8, you're putting more on the x. You want the x to be by itself. Right. This is as low as we can get. If you want to make it a decimal, you can. It's 4 point something.
4 3/8.
Yeah. Or just leave it like that. All right, we good? All right, if you are a large writer, turn to the back. You need some space on this next one. You need some space on this next problem. All right. I am warning you. I'm letting you know right now. You need some space for number 5. Okay? What's different about 5 this time from our other ones? There's an X on the outside and on the inside, right? We have 2 X's going on. So we still need to isolate my radical if I can. Okay? So what do we do with that 3X on the outside? Yes, say it is. Subtract. Yeah, we will subtract 3X first. Okay? This gives me negative 5 times the square root of X is equal to 2 minus 3X. Okay? Okay. What could I do next? We could divide by negative 5. But let's think about this. If I divide by negative 5, I have a big old fraction. And then I have to square that fraction. So would you like to do it where you don't have to square a fraction? So let's go ahead and square it now. Yeah, we can. Watch me. Challenge accepted. Because what is negative 5 squared? And what's square root of X squared? So this becomes 25X. My other side does not become 4 plus 9X squared. Don't do it. Because remember this. This really becomes, what is that? 4 minus 6X minus 6X plus 9X squared. Like that. Okay, so I've put another X in there. Now there's 3 of them. But that X squared should be ringing bells in your head. Bells should be ringing. What'd you say? We got a factor. Yeah. So let's subtract 25X over so we can be with his friends. So that becomes what? Minus 37X plus 4. What? Oh, yeah, you were on fire. Again. Slip and slide. You will be today. You will be. Yeah, we're going to slip and slide, which is kind of nice because this becomes 36 on the end. What multiplies to give you 36 but adds to give you 37? 36 and 1. Both, since 36 is positive, they're the same sign. Since 37 is negative, they're both negative. So X minus 36 and then X minus 1. So now we got to slide my 9 back out. So we have X minus 4 and 9X minus 1. So the 2 answers we have are X equals 4 and X equals, what, 1/9? If this was equal to 0, you would add 1 and divide by 9 to get X by itself. Don't circle.
Oh my god.
Well, it was a square root. We got to check. It was a square root. We got to check. Okay, so we got to plug it back in. Do you want to check the 4 or the 1/9 first? The 4? Okay. I'm going to plug it back into my original problem. Okay, so it's going to become 3 times 4 minus 5 times the square root of 4. We need to see, does that equal 2? All right. 3 times 4 is 12. Square root of 4 is 2, right? That becomes 12 minus 10. So 2 equals 2. So does 4, do we like 4? Yes. We like 4. Alright, let's check 1/9. Plug it into our original. We'll come up here. 3 times 1/9 minus 5 times the square root of 1/9. Does that equal 2? Okay. What is 3 times 1/9? 3/9, which simplifies to 1/3. Good. What is the square root of 1/9? Think about it. What's the square root of 1? What's the square root of 9? 3. So what's 5 times 1/3? 5/3, -5/3. What is 1 minus 5?
-4/3.
It becomes -4/3. Does that equal 2? No. So we don't like 1/9. Okay, so our only solution here is 4. Yes. And guys, 90% of the time when you get 2 answers like this, one of them won't work. Okay? So you got to make sure if it's a square root. Now, if we did this and it was a cube root, it wouldn't matter, right? We're done. But square roots, we got to check them because like here, -4/3 is not 2.
Why don't we check it first?
We do check it for a square. Cube roots are okay because you can have negative cube roots. Like the cube root of -8 is -2. Because -2 times -2 times -2 gives me -8. Yeah. It's behind you, 55. All right. All right, let's do number 6. Stay with me, guys. Guys, that you've already accomplished the hardest one we're going to do today. Okay? You've accomplished the most difficult. What do you notice about number 6?
It has 2 square roots on each side.
2 square roots on each side, and they're isolated. So what can I go ahead and do to both sides?
Step 2.
Yeah, go to step 2, which means to square them both. So this becomes what? X minus 10 equals 2x? No. Because all of x minus 10 was in the radical, so when you square that, just the radical goes away. You okay? So now I'm going to, what do you want to do, subtract x? So we have -10 is equal to x. Okay? We do have to check it because it was a square root. What's -10 minus 10? What's 2 times -10? Now we don't like negatives, but that's a true statement, right? Even though we don't like negatives under radicals, the square root of -20 is equal to the square root of -20. So this is one of the situations where that answer was going to be okay and it's going to work. So x does equal -10. Questions so far? Not yet. Okay, moving on. All right, the next section that we're going to do, solving radical equations, but now with exponents. Now remember, an exponent of 1/2, like if I had this, isn't that the same thing as the square root? If I had x raised to the 1/3, isn't that the same thing as a cube root? Right? So remember that. So, question. Guys, my turn. X to the power of 1/3 equals 3. Okay? We just talked about how that's the same thing as saying the cube root of x, right? And how would you undo the cube root? You would cube both sides. Now, when I leave it like this, watch what happens. If I cube both sides, then from power to a power, you multiply. What is 1/3 times 3? Yes. Okay? So when we do it with our exponents, we want to bring the power in. That's going to make that first exponent equal to 1. Because now we get x equals 27. Because 1/3 times 3, that cancels out. So what about 8? What power would I bring to both sides on 8? I would bring a power of 2 to both sides. If you do it Swen, you gotta do it. Remember, there's already an exponent of 1 right here. Right? So 1/2 times 2 is just 1. But what's 1 times 2? 2, 4 squared is 16. Okay? So you're trying to find the exponent that's going to make it equal to 1. And it has a name. What's that name of that exponent? What? The reciprocal. Yes, the reciprocal is what you use to always make a fraction equal to 1. So what's the reciprocal of 5 over 6? 6 over 5. Okay? Come on. Why are you not working? No. All right, x to the 2/3 equals 4, right? All right, to make this equal to an exponent of 1, I have to multiply 2/3 by 3 over 2. Good. Okay, because 2/3 times 3 over 2 gives me just x. So we have x is equal, 4 to the power of 2/3 is saying the square root of 4 cubed. What is the square root of 2? I mean, dang it. What is the square root of 4? And we always root and then power. You can do it the other way, but if you root first, you're working with smaller numbers. Yeah. All right, we have plus and minus 2, right? Square root of 4 is positive and negative 2. What is positive and negative 2 cubed?
8.
Positive and negative 8.
Oh my god, I got that answer, but I didn't do it. Wait,
Okay.
so why couldn't you have done, like you put it, so you put x
Mhm.
regularly and then do it cubed on the outside and then 2 on the inside, which gives you, and then you would divide, or do the 3.
You have to do the 3 over 2. What do you mean? Hold on.
Because when I did it, I did x,
Did you do this?
yes,
So you cubed both sides?
yeah, and then I did the 4 cubed, which gives you 64. And then I square rooted it.
Mhm.
You just have to do, oh,
Same thing.
okay.
Yep. Same thing. All right, next one. What's different about number 10? It's a negative. So, if it was just 2, 2 times what gives me 1? 1 over 2. Good. And what makes the negative go away? If we multiply by another negative, right? Negative 2 times negative 1/2 will give me positive 1. Right? Do it to one piece. We gotta do it to the other piece. Guys, please stop. Thank you. All right, so we do have x by itself. But remember, a negative exponent means what happens to 49? It's going to fall down. So it becomes 1 over 49 to the 1/2. Exponent of 1/2 is the same thing as a square root. What is the square root of 49? And negative 7. Because it was a negative exponent. So it means it fell down. Oh man, come back. A square root Guys, whenever you take an even root, you're going to have a positive and negative. Because it takes two positives or two negatives to give you a positive number. Right? So that's why we have positive and negatives when it comes to our even roots. Because of the negative 1/2. We took 49 and raised it to the negative 1/2. The negative exponent means it had to fall down. Do you understand why we chose negative 1/2?
It's so boring.
Are you good?
Oh, wait, you had to add something. It's worthwhile. It's not worthwhile.
Okay. All right, moving on. Here we go. 4 times x to the negative 1/4 plus 6 equals 7. What can I do first? Let's subtract 6.
Can y'all shut up?
It would be nice. All right. Do I have my variable by itself yet?
No.
No, so what should we do?
Multiply by 4.
Divide
by,
Let's divide by 4.
I thought we didn't do that first.
We gotta get the x by itself. So we have x to the negative 1/4 is equal to 1/4. Okay. Yes, what is the reciprocal of 1/4? 4/1. Good. And to bring that negative away, we had to do negative 4. Like that. So negative 1/4 times negative 4, that's going to cancel out. We got that negative again. 1/4, both of those get the negative 4 exponent. So the whole thing is going to flip over.
Wait, why are you flipping it?
Because it was negative 4.
Yeah, those are the
My exponent, yes, so the 4 fell down, but the 1 went up. Or the 4 went up and the 1 went down. They're switching spots. The whole thing has a negative exponent. So all pieces of my fraction switch. Okay, now we get to raise it to the power of 4. What is 4 to the 4th? And what is 1 to the 4th? Just 1.
plus or minus?
We didn't do the root. We rose it to a power of 256, so we can leave it just plain 256. We get plus minus when we do cube roots or square roots or fourth roots. All right. All right, let's move on, please, to number 12. Can we subtract 1 this time? No, why not? It's in parentheses, okay? So what are we going to have to go to next?
Multiply by 3.
Well, we're not multiplying by 3/2. Careful.
You know what I'm talking about.
Yes, we are raising both sides to that, which means you multiply your exponents. But I don't want you to think you're multiplying that side by it. Both sides get an exponent of 3/2. Guys, stay focused to me, please. Thank you. They both get the exponent of 3/2. Because that way our exponents cancel out. We get just x plus 1. But now it equals to the square root of 4 cubed, right? What is the square root of 4? 2 and what's 2 and negative 2 cubed? 8 and negative 8. So we took this. So it was the square root of 4 cubed. The square root of 4 is positive and negative 2. And then we cubed that to get positive and negative 8. That's where that came from. I wrote them separately because when I subtract 1, I have to do it from 8 and negative 8. We're going to have two different answers here. So we're going to get x is equal to what? 7 and negative 9. Yep. Okay, good question. Someone asked if we should check it. The original one was a cube root, so we didn't have to. What's wrong? Kaylee, talk to me. Do you get why we got 8 and negative 8? Okay, do you understand why we have 4 raised to the power of 3 over 2? Okay, so from there, I simplified that piece. So 3 over 2 means a root of 2 and a power of 3. You go with that? Okay, the square root of 4 is 2 and negative 2. So when I cube that, I have to cube 2 and negative 2 to get 8 and negative 8. Good? Okay. All right, how about you do this last one? I've done 12. You can do 1. You do number 8. You do number 13. You do number 13. All right, so yes, positive and negative 8. What exponent, I'm talking, you're listening. What exponent did we bring to both sides? 3 over 4. Let me change my color, it's easier to see. Okay. So after this, your exponents cancel, right? Simplify 16 raised to the 3 over 4. That's the same thing as saying the 4th root of 16 cubed. Whenever you do an even root, you have a positive and negative, okay?
So we take the number that's on the bottom.
That's the root. Yep. The 4th root of 16 is positive and negative 2. 2 and negative 2 cubed gives me 8 and negative 8. Like that. Okay? All right, so you get 10 minutes to work on your homework. And yes, you will work on your homework. This does not mean class is over. Okay? Notes are complete, so you will work on your assignment. Make sense? Okay. We are going to do page 395, 18 through 35 all, but you will not do 24 or 25. Okay? If you want to take a picture of the actual book, come see me. 34. Sorry, 18 through 34 all, but don't do 24 or 25.